Did you know that the sun is so big you could fit 1 million Earths inside it? Now that's a lot of room. But it's not just its size that's impressive. The sun, a star at the very heart of our solar system, is also a cosmic marvel teeming with energy and mystery. Now you might be wondering, what is the sun made of? Well, it's primarily composed of hydrogen and helium, two of the lightest elements in the universe. The sun's intense heat and pressure fuse these elements together in a process called nuclear fusion, creating a colossal amount of energy. But remember, even though the sun might look small from where we stand, it's actually a gargantuan sphere that dwarfs our home planet. Its vastness is truly mind-boggling. So next time when you look up at the sky, remember there's a gigantic ball of gas out there that's 1,000,000 times bigger than our home planet. Guess what? The surface of the sun is actually cooler than its outer atmosphere. Surprising, isn't it? Let's dive right into this fiery celestial body. The sun's core is the hottest part, with temperatures soaring up to an immense 15 million degrees Celsius. This is where nuclear fusion occurs, converting hydrogen into helium and releasing a tremendous amount of energy in the process. As we move outward, the temperature drops. The radiative zone, the layer after the core, is still pretty hot, with temperatures around 7 million degrees Celsius. Here, the energy produced in the core travels outwards as electromagnetic radiation. Next up is the convective zone, where energy is transferred by convection, kind of like how boiling water moves in a pot. The temperature here cools down to about 2 million degrees Celsius. Now we've finally reached the sun's surface, also known as the photosphere. Here the temperature is a relatively chilly 5,500 degrees Celsius. This is the part of the sun we can see from Earth. But things get weird when we move into the sun's outer atmosphere, or the corona. Instead of continuing to cool down, the temperature jumps back up to a few million degrees. Scientists are still puzzled by this phenomenon, known as the coronal heating problem. Let's not forget about solar flares and sunspots. Solar flares are sudden explosions on the sun's surface that release a lot of energy. They can affect Earth by disrupting satellite communications. On the other hand, sunspots are cooler areas on the sun's surface, appearing as dark spots. They're caused by the sun's magnetic field and can last for a few days to a few months. Imagine that. Our sun, with its hot temper, is full of cool spots and fiery flares. Did you know that the sun is like a giant power plant? It's constantly converting hydrogen into helium and releasing a huge amount of energy in the process. Imagine having a power station so colossal that it could keep our Earth warm and bright for billions of years. That's our sun for you, a real powerhouse. Now let's dive into the heart of this celestial factory to understand how it works. The sun's core is where the magic happens. It's so incredibly hot and pressurized that hydrogen atoms get squeezed together to form helium. This process, my friends, is called nuclear fusion. Picture it like a massive, never-ending party where hydrogen atoms are constantly coming together, creating helium and releasing energy. It's this energy that makes the sun shine brightly in the sky, but it doesn't stop there. This energy, in the form of light, takes a whopping 100,000 years to make its way from the sun's core to its surface. Once it reaches the surface, this energy is sent hurtling across space. And guess who's waiting to catch some of these energy-packed rays? Yes, our very own Earth. It takes around 8 minutes for sunlight to travel the 93 million miles from the sun to our planet. This sunlight is incredibly vital for life on Earth. It's what wakes us up in the morning and gives plants the energy to perform photosynthesis, which in turn gives us the oxygen we breathe. It's also the source of all weather and climate on Earth, driving the winds, the rains, and the seasons. So the next time you feel the warmth of the sun on your skin, remember you're feeling energy that was created in the core of the sun millions of years ago and has traveled a vast distance to reach you. So the very energy that lights up our world and helps plants grow comes from the sun's powerful heart. The sun has been shining for about 4.6 billion years, but it's only middle-aged. Just like us humans, the sun has a life cycle. It's born, it lives, and yes, eventually it will die. But don't worry, we've got plenty of time left with our star. The sun is currently in what's known as its main sequence stage. This is when it's in its prime, fueling itself by converting hydrogen into helium in its core. sort of like a human being in their 30s or 40s, full of energy and life. And guess what? Our sun still has about 5 billion years left in this stage, so it's not going anywhere anytime soon. After that, it will enter its old age, swelling into a red giant before eventually shrinking into a white dwarf. Just think of it, our sun is a cosmic middle-ager with billions of years to go. Wow, we've learned a lot about our sun today, haven't we? We've embarked on a journey to understand the cosmic marvel that is our sun, discovering its astounding size, that's over 100 times the diameter of Earth. We felt the heat as we delved into the sun's scorching surface, which reaches a staggering temperature of millions of degrees. We've marveled at the sun's role as an incredible powerhouse, producing energy that lights up our world every single day. Then, we've pondered over the sun's lifespan, a mind-boggling 5 billion years, with another 5 billion to go. It's fascinating, isn't it? So don't stop here. The universe is a vast and intriguing place, full of mysteries and wonders, just like our sun. Continue to seek, explore, and learn. This is all from Space Kid for today. Remember, the universe is full of wonders waiting for you to discover. Subscribe for more exciting space adventures. Until then, keep your curiosity alive and keep exploring.